Question number 3. An object is released from rest. Okay, object is released from rest. Here u equal to 0 and slides down a frictionless ramp. The object then leaves the ramp and slides along a horizontal surface. Okay, so it comes all the way over here, and then from here it starts sliding down like this, and it stops here because there is a friction. Object stops in a distance here along the ramp. Okay, the coefficient of dynamic friction between the object and the rough surface area is mu. Okay, let me move my photo here. Is mu over here. So therefore, here it is mu over here. What is the height of the ramp? What is the height of the ramp? Okay, so now what we need to do? First, let us apply the kinematics principles. So if this is u over here and it starts moving over here, then what can happen? We can now write something like v square is equal to, or maybe I'll use mgh. Here the energy is mgh, and when it reaches here, this is half mv square. Half mv square. So what I will write is half mv square is equal to mgh. Why did I do this? The reason is because whatever energy it has here, it has been spent in increasing the velocity. So I can write like this. So this m and m goes away where m was the mass of the object. So v square is equal to 2gh. We have got one equation. Okay. And now, so this velocity which is here forms the initial velocity for the second motion in the horizontal motion. And as it comes downwards, as it keeps on sliding like this, the velocity keeps on reducing, and when it reaches here, this velocity becomes 0. Why becomes 0? Because it stops, right? So therefore, now what we can do is we can apply the equations of motion. How do you apply the equations of motion? You apply it like this. You say that v square is equal to u square plus 2as over here. What is v? V is 0. Okay. U. What is u? U is nothing but, okay, let me write u square itself. U square plus 2 into, what is a here? A is nothing but, a is equal to minus mu times g. Why minus mu times g? The reason is because what is the force acting here? Okay, the net force acting here is always in the opposite direction. What is that? Frictional force. Frictional force is equal to mu times n, which should be equal to mu times mg. Now what I can do is, I can now say net force is equal to ma according to Newton's second law, and I can now write this as mu times mg. And what is the direction of this? Negative. It's like this over here, right? So therefore, I can now put negative over here. This m and m cancels, and thus you can get mu a is equal to minus mu times g, right? That's what I have got here. Okay, now I can substitute it over here. Which equation? Where is that equation? It's here. Minus mu times g multiplied by s. Now what will I do? I will now solve this for it. I'll get u square is equal to 2 mu gs. Okay, we have got the second equation. But what is u? The velocity at this point, which is also the same velocity as it keeps on coming downwards over here, which we got it from here, right? So therefore, we can equate 1 and 2 here. When I do this, what do I get? 2 times mu times gs is equal to 2 times gh. 2 and 2 goes away, g and g goes away. What do I need? I need the value of h. H is equal to mu times s, right? H is equal to mu times s. The answer is D over here. Okay.